Silence. Here we go. All right. No. Okay, so number one. This is why, you people, okay, to not know this. What is this? What's the first one? It's a parabola. I just got all four answers, by the way. That's great. Test Wednesday. Why is it a parabola, by the way? 1 squared. What's the next one? Now, this is a little trickier. There's only two possibilities. It's an ellipse, not a circle. There's a 4 in front of this y squared. So what will happen? I mean, okay, this isn't really complete the square. It does say put it in standard form. When I subtract or add that 4 and then divide by 4, you get y squared over 1. So there you go. You got a different y-axis radius than an x-axis radius. That is why this is an ellipse. But you should be able to identify that before. You have two square terms. Both are positive or the same sign. So that has to be an ellipse with the different numbers there. What's number 5? By the way, I can't count. 1, 2, 5. That's a parabola. How are we not getting that? Some people are writing them in now because they didn't listen to me. Oh, Jim, jacking around during class, not paying attention. All right? You're supposed to get these done right away. Why is it a parabola? 1 square term. What's the next one? Focus on this. Now, it's going to be complicated. We'll complete the square. Which got there down? Oh, I thought that was a phone. All right? I was about to go off on somebody. All right? But that's an ellipse because you have positive, 2 squared terms, different coefficients. When you divide, you'll get different x and y-axis radii. So it makes an oval. No minuses. All right? So what's the next one? What's 7? He's not letting anyone answer these. How in the world could that be a parabola? Sorry, I don't mean to get on you, but you're just saying words. It's a circle. You have an x squared and a y squared, and the numbers are the same in front of the x and y squared. It could even actually be, I've done this in all 3 classes now, it could actually be 5x squared plus 5y squared plus some other stuff. That would still be a circle because when you divide, you'll end up with the same x-axis radius as y-axis radius. What's number 8? If you get this wrong, just get out. We will in a minute. Just, God. Okay. What is that one? Shh. That has to be a hyperbola. You have one of the minuses on the squared terms. That's what made or defined a hyperbola. Then we had to do different things to graph it. Just to keep going with this, what's number 10? I know I'm being rude, but they're supposed to know this. And I'm getting all these different answers again. You're not doing any thinking. Parabola. Line. Someone said line. What? The equation of a line? What is it? Ah! It's a circle. I know. I said let's do 10. Go straight down. And you said ellipse for number 9? Parabola. Okay. Man, maybe I should put this on. It seems like a lot of animosity between teacher and students. Okay? That's parabola because there's only one square term. The last one's a circle. Okay, now, just for time purposes, I could complete the square net. I'm not. I'll do number 10. We're going to start off with this one and actually complete the square. And then I'm going to graph just for purposes of review. Shh. Okay, no. Tell you what that is. Okay, so first off, 9x squared minus 18x. And again, this is just lecture today. We got no time. If you don't know these things, this is all 100% review, right? We pull out a 9 and that becomes minus 2x. Okay, then plus blank. So really completing the square is 2 to 3 steps. All right, and then I don't have time for colors. 25 and 50, you pull out a 25, 150, but it's not really about the 150. You have to pull out 25. And then that conveniently becomes 6y minus. And then what do you do with this 9? But how do you just put it over there? Minus. You guys screw that up. Stop doing that. And then whatever I do to one side, you do to the other. Okay, class, what's the first blank? 1. Try to be faster than him. What's the next blank? No. Okay, now be careful. What's this blank here? It is 9 times 1. What's this blank? 225. 9 times 25. Because again, you didn't add 1, you added 9 times 1. You added 25 times 9. So you have to balance that out. Next step is to speed this up. 9x minus 1 squared. Sorry, third hour. We didn't get your video because I forgot to turn on the microphone. So it would have been just a quiet, wouldn't get all my yelling at the students in there, which is not a Samulus video. Never mind. I had the mic off. I yelled at third hour consistently, but it was all quiet.
Can you say my name in the video?
No. Oh my gosh. Which it is. Jesus. Okay. 9 goes into 225. 25?
He's right.
25 goes into 225. 9. Shh. Need to focus today. We got a test. Okay, now, I could graph this super fast. And I'm going to do it just to, So the center is 1, 3. 1, 2, 3. Real quick scratch. And then I go 5 right and left, correct? This is why this is an ellipse. Why we would, 9x squared and 25y squared. When it comes to the division part, you're going to get a different x-axis and y-axis radius, which makes an oval, not a circle. 3, 4, 5. And then 5, 1, 2, 3, 4, 5. Just real quick sketch, just to remind you of graphing, because this, we could count this as a review day. This really is all completing the square we've done in all of these. So 1, 2, 3, and then just 3 up, something like that. So you'd have something like that. And then what's C? Well, C squared equals A squared minus B squared, because it's got to be smaller. So that's 16. What's the square root of 16? 4. So then you go 4 which way? Up and down? Well, then 4 is bigger than 3. Is that how ellipses work? No. Remember, the sun is in the ellipse. I'm sorry, the focus position for Earth. So it's right and left. So it does end up inside. So go 4 right and 4 left, and then you can count what these are and label what the coordinates are, just through grade school stuff. By the way, eccentricity is just C over A. C is 4, A is 5. 4 over 5. Not rocket science. But it is rocket science. All right. Next one, we'll just stick with this. These are the harder ones to do. Okay, so 3x squared. I should make you do these, but, just because of time. Tomorrow we'll do something similar. And then minus 4x, and then get that blank ready. And then you have to pull out a negative 1, or a negative. If you don't want to write the 1, that's fine, but get the negative out there. What's that make, 12y? Yeah, don't forget about that. Plus blank. And then negative 45 to get it over here. All right. What's the first? Oh, sorry. Blankety blank. Okay, what's the first blank? 4. Half of negative 2, or half of negative 4 is negative 2. Negative 2 squared 4. He's already going over there. But what's this next blank? Half of negative 6? 36. Oof. All right, and what are these blanks? This one is 12, 3 times 4. And then this is negative 36. All right, and then 3, x minus 2 squared. And then plus a negative 1, just make it minus. Just get the minus taken care of. Y minus, anyone? 6. Negative 6 times negative 6, negative 6 plus negative 6. All right, and then this becomes negative 69. All right. Don't. All right, now, okay, when I divide, watch what happens. Hey, what has the minus sign right now? What has the minus sign? The y. What happens when I divide by this negative, though? What's going to happen? It's going to switch who's negative. Doesn't the negative now reside in front of the x squared? So probably a smart way, don't call me smart, Common Core. This becomes positive. This becomes negative, and that's how we're going to write it. And actually, 3 does go into 69 23 times. Now, we're not going to have a nice graph for this, but I'm going to reference it. but not find specific numbers, all you'd have to do is go to your calculator and get square roots. Okay, but okay, first of all, the center is 2 comma 6, not 6 comma 2, right? 2 comma 6. And then, okay, fine. I'd have to find the square root of 69, which is square root of 64 is 8. So it's 8 point something up, and then 8 point something down. And then the square root of 23, which is 4 point something. I'd have to go 4 point something right and 4 point something left, and then I draw a box. You know, you just find those numbers. You could do it. It's not a big deal. Right? And then the asymptote would cross through this, and then this would go up, down. So there's a real super fast sketch of this. And then how do you find the foci? What do you do with 69 and 23? You add them. So yeah, 89, 92. The square root of 92 up and down. That's all I'm saying. Okay. What's that? Y in front, that's up and down. Y squared equals x minus x squared, I mean. Y squared is the good axis. Do not do that with a parabola. We'll talk about that at the end there. All right, so, and then we'll just move on. All right, quick sketches, the ideas, why it's just a little bit different than an ellipse minorly. Couple other things. Oh, this is easy. What's this picture of? Oh, we already got it. Circle. What's the blank? 16. What's the blank? 25. Whatever we do to one side? We just had 0 over there and had no number to shift over there. So I just wanted to write that so you were clear. I'm not graphing this one. Circles are so easy. What did I do wrong? Did I do something wrong? No? Why did I do what? Negative 4, 5. What's the radius? Square root of 41, which is 6 point something. You go to negative 4, 5 and go 6 point something. Up, down, right, and left, and have a circle. All right, then the last one. I had 2 other parabolas up there. I wanted to pick this one, though, because it's not as difficult as you think. Do you like fractions? It's okay. No, you don't. Okay, but I try to make you do fractions here and there and not be afraid of them. This is one of the cases where you want to get rid of them. What can I do to both sides? This is a general, basic mathematical concept. What can I do to get rid of these? This has nothing to do with ellipses. What can I do to get rid of the, I said ellipses, parabolas, conic sections in general? What can I multiply both sides by? I don't have time for this. 8. Okay? 8. What's 8 times 0, by the way? Still 0. 1/8 of 8? What's that? X squared. What's half of 8? I don't know. 4. Expect me to do fractions. Minus 8y. Now what's half of 8? 4. What's 4 times 9? Okay, now, which way is this going? Is it going to go up, down, right, or left? Well, there's 2 choices that are legal. It's either up or down. Did you hear what he just said? X squared or right and left. This is what is a common error. We convolute our file for hyperbolas with our file for parabolas. Wrong. Okay? No, I know. It's okay. So remember what we said? For every y, there's what? For every y, there must be 2 x's because of that I squared. So let's just graph. Let's pretend we graphed a y. For every y, there's 2 x's like that. See? 1 y, 2. So what does that have to be? Either up or down. So it's an up-downer. See, as soon as we do hyperbolas and we say good axis, bad axis, we convolute it with parabolas. They have nothing to do with each other. Nothing. Keep the files separate. As far as one side of your brain, put the hyperbolas. The other side, put the parabolas. Keep them as far away as possible. You can do whatever you put your mind to. He isn't. No, you're not taking notes. You never have. All right. Well, that's what we just said. You're not taking notes, and you haven't since August. So, all right. So, right? Now, okay, and the other thing I didn't finish through that other Why is it like this? Because here's the format for a parabola, which says everything that's not squared needs to be shoved over to the other side. So this is the one time that, another time where parabolas are a little different. When you complete the square, we got to do a little different thing. Only complete the square on the squared part. Everything else goes away on the other side. And what's the number? And this is easy because now, I don't have the problem with the ellipses and hyperbolas. Is it really 4 on the right side? Well, yeah, it is. And that's x minus 2 squared. Okay, now, this is negative 32. I'm going to pull an 8 out. And then 32 divided by 8 is 4. All right. So for every y, there's 2 x's. So we understand this goes up and down. The vertex is nice. It is x comma y, and in that order, so we wouldn't screw that up. I'll graph this over here, 2 comma 4. And then which direction does it go? It goes up. So what's p equal to? What's p equal to? 2. So I p up, and I p down. What kind of line is that? Dotted, red, straight?
Horizontal.
Horizontal. So the focus is 4 comma 4. The directrix is not 2 comma 2. It's y equals 2. That's about all I can think of. Oh, okay, fine. Focal width. We could go 4 right and 4 left. That's a grand total of 8. 1, 2, 3, 4. 4, 2 more. Whoa, did I do that one wrong? I think my scale's way off. That's why that looks awful. Yeesh. That's terrible graphing. Okay, I squeezed the first 4 on the right. That's why it looks all cattywampus there. All right. And that's about all that we could talk about with parabolas as far as graphing. So cannot overemphasize. Do not screw up hyperbolas and parabolas with the whole good axis bad. That's only for hyperbolas. For every y, there's 2 x's. If it was a y squared, equals 4px. For every x, there's 2 y's. And here they are, they ain't listening. This is why they screw it up all the time. For every x, there's 2 y's. What's the only way that can be drawn? There's only 2 ways that could be drawn. Left or right. It's one or the other. Then when you get the real specific numbers, then you can know which one it is. So, correct. Okay, I didn't write any of this down. So each period, I don't know if I've crossed off the same numbers or not to not do. This is what 6th hour. What hour is this? 5th. It's 5th hour, isn't it? Yeah. This is what 5th hour is going to do. I picked 5 questions each hour. I don't know if they're all the same. Whatever. So that's what they're going to do for homework. Because now we're going to go to systems. Because we should be able to handle this. Don't worry about it. Everyone's always like, I hate these. I don't even know what it is yet. Okay? Shh. Now, don't write any of this down. And then what usually happens was when I say, do you remember doing this? What do you always say? No, I don't remember anything. Teach it all, brand new. All right, so, but I hope you at least remember solving systems, at least the idea of it. Nice. I like it. Okay, so what you had back in the day was solving systems of equations of lines. And the first way that you had to do it was by graphing. And the solution to the system is where the 2 lines what? Cross. And then you pull that coordinate out, and then that's the solution because it actually satisfies both equations. Fumble. Okay? Well, just right back at you, huh? It's just an amazing situation there. Okay, now there's 2 algebraic methods to solve a system. Remember what that is? Shh. What are those 2 methods? No? Nice. Substitution and elimination. Why those are better? Do lines always graph nicely and cross at a nice little perfect coordinate? No. You could get a decimal answer. Or look at this one when they solve this algebraically. But this is just for recall, for understanding substitution is one possibility. What you could do, I don't want to break my neck here. What you could do is solve for one of the variables and then substitute it. So they solve for x. That's what this is showing. And then in the other equation where there is an x, they substitute that negative 3y plus 3 in, and then they solve for y, and then after they get y, they plug it in to find x. The other one was elimination, which is my favorite. Elimination, you have this system, and then you maybe see that the x's go away nicely if I multiply the top equation by -2. Then I get opposites for the x's. And then they would cancel when I add them. And then I'd get y equals -2, then I'd substitute the y equals -2. Shh! Now, look at both these answers when we did this algebraically. -30, 11, that'd be awful to solve by graphing. You'd have to go left 30 and down 11 to see where these two lines cross. I'd have to graph all the way out there. Or is -4/3 good graphically? Would that be obvious? No, you'd have to guess that it's not a perfect x value and guess what that x value is. Now let's think about conics and how they graph. Let's take a line. How many times can a line hit a circle? Maximum. Twice. Minimum. 0 still. You could have a circle here and a line here. I'm doing something. Okay, this is what I did in class. You could have a circle here and a line there. Do those cross? No. How many times maximum can a hyperbola cross a circle? 4. All right, so what this was in our Algebra 2 book back in the day when math made sense at library. Oh, what? And they had these neat little drawings. Yeah, you could have conic sections. Well, actually, they like lines with a conic section. You still could have no intersection. Any line with any conic section could be 2 maximum. But then you could get a whole bunch of, well, of course, you could have no solution with a circle and a hyperbola. It's possible. Remember what happens mathematically. You just get a mathematical error algebraically. And that's what's going to happen with us. And you can have the next things, you can have anything from 1 to 4. 4 maximum, though. 4 is the maximum. Hold on. Just brought up a good point. What if the equations were secretly exactly the same? Then that would be an infinite amount of solutions. All right, so therefore, a conic system can have from anywhere from 0 to 4 solutions. So here's what I'm going to do. You don't have to do, okay, by the way, did I graph everything so far today? You have no graphing to have to do. On the systems, just solve the systems when we get to it. Did I finish that? Oh my gosh, no I didn't. Whoa, what did I do? Wait, no, never mind. I'm all screwed up. I am. That's old age. Hey, just when you're bored, like 23 years old, and I'm still teaching, you should pull up those YouTube videos when I'm taping those. Oh, it's gonna get worse every year. Gonna get worse. Divide by 30. Hey, what is this, by the way? What is this? What is that? It is. It's an ellipse. Divide by 36. 4 over 36 is 1 over 9. And then this is over 36. Okay, so when we're actually solving these systems, you're going to do no graphing. But I just wanted to review graphing, review what we're supposed to know. Like I go right, left, 3, right. I go up, down 6. 1, 2, 3, 4, 5. This is so easy. 1, 2, 3, 4, 5, 6. I hope I counted right. And then this would be what the ellipse looks like. Just trying to pictorialize this for you. All right. By the way, what's 36 minus 9? 27. I got it. All right. Square root of 16 is 4. Square root of 25 is 5. So 5 point something, and it's up 5 point and down 5 point for the foci. Just I wanted to add that. You know, it's really simple to find the foci. Okay, now let's graph the other. What's this thing? What's this? This is a hyperbola. There's a minus in the middle. So divide by 4. They have 4 underneath each one of them, right? So it's up, down, right, left, 2. But what do I draw? A square in this case. We usually say a rectangle, but specifically this is a square.
Wait, circles only have pluses, right?
Yes.
Just making sure. Got a big test on Wednesday.
Okay, and then which way does it go? Left and right. So I just drew those just to give a good picture. Hey, Does this look like I could guess what the exactly
No.
what these are?
No.
How many answers are there though? 4. Okay, so you never have to graph to solve a system. I just was doing this to remind you how to graph these parts. By the way, the foci are 4 plus 4. Square root that, the square root of 8. So the foci are 2 point something right and left. They do end up in the bowls. Just, the review. But now what we're going to do is solve the system. And what is this set up for? What did I just do there? How am I going to solve that system? Elimination. It's no harder than it was with the lines when you solved systems of equations of lines. Because who's going to cancel right off the bat? Y squared. So you add the two equations together. The y squareds cancel. And then you solve for x. You're going to really tick me off here. What's x equal? Square root of 8. Oh, I was about ready to, like an umpire. You're gone! Burn 'em. It's plus minus 2 root 2, the square root of 8. Come on. Square root of 8 is 2 root 2. Good, because you were sleeping. You were about to go down. You almost broke your neck on that little... Okay? 4. Now, guess what I'm going to throw in here? I'm going to go back to the 8, square root of 8. Because what's the square root of 8 squared? 8. So 2 root 2, you put it in there, and the students mess up squaring 2 root 2. It's the same thing as squaring root 8. All right, plus y squared equals 36. This is 8. This ends up 8. I'll just write that so we don't go too fast. And then that's 32, and I subtract 32. And that becomes 4. So what's y equal to?
2.
Ah!
Plus or minus 2.
Plus or minus 2. Bums.
20 jimos.
That's since August. I've been talking about the burn, burn, burn. Some of you, I think, literally like just burn. Ooh. I don't know, because you keep doing it over and over and over again. Okay? All right. So now, there's 4 answers. 2 root 2. 2. Negative 2 root 2. 2. Negative 2 root 2. Negative 2. And then 2 root 2. Negative 2. In all 4 quadrants. It's so much. Okay. But, wait, I gotta wait. Hold on. Alright. What's this a picture of? First one. You don't have this on your papers. What's that a picture of?
And is a picture of a
Some people aren't looking. Not an ellipse. Not a hyper. Are you okay? Looks like you're drifting. It's a circle. Of course it's a circle. What's the second one? I don't know. I never saw those. How you put that? It's a line. You should know that from 8th grade. That's a line. How many times could a line hit a circle? Twice maximum. Blank? You don't have to do all that. I'm doing a whole bunch of, a big thing of review of all the things that we've done with these things. What's the blank? What's the blank?
1. 1.
What's the other blank? And that's what's great about circles. These are both 1s because you don't have to worry about a multiplier out in front. So just doing this, you don't ever have to graph with systems. I'm just putting a whole comprehensive thing together about completing the square, knowing how to graph, knowing what key attributes are, so on and so on and so forth. 1, 1. And then radius is 2. How do you graph a line? You find the what? Slope. I'm going to graph this in green. And actually, we need this for how we solve this mathematically. Well, this one we get lucky. Get ready to get excited. If you don't know that the y-intercept is 4, get out. Down 1 over 1. Oh, anyone excited? Down 1 over 1. Down 1. Oh, anyone excited? Okay. Because we already know what the solutions are. We're still going to find them mathematically or algebraically. What are they? They're just numbers. You didn't even look, did you? It's 1, comma, 3, and 3, comma, 1. Because that's what it means. No, it's just, oh my gosh. All right. Okay, but now, can I solve this algebraically by elimination? No. I can't cancel the x squareds and the y squareds. I don't have an x squared or a y squared. So I must do what? Substitution. This does stink because I have 2 spots I have to substitute it. By the way, good FOILers are? Wrong. That's it. Yep. So you should know how to FOIL because of how many times we FOILed factored in this class. I have to plug in negative x plus 4 for this y and for this y. It actually is not going to end up being too bad here. Okay, x squared minus 2x. Negative x times negative x, positive x squared. Negative x times 4, negative 4x twice. It's negative 8x. And then 4 times 4. Distribute a negative 2. That becomes 2x minus 8 equals 2. Now I have to cross these off after I get them like termed here. 2x squared. Because I get too much. Too much is being seen. So this is negative 10x. Ooh, negative 8x. Okay, so that 2x and negative 2x actually canceled. And then this becomes 8, but then I have to subtract 2, so I get 6. So I was able to put all that in my head and do a bunch of steps at once. We should be able to do that in our mathematical careers right now. By the way, what's in common of all these terms? 2. And can I divide both sides by? That's a plus, right? Made a mistake there. I said 6 and I wrote minus 6. I don't know why. What can I do about that 2? No time. Divide both sides by it because what's 0 divided by 2? Still 0. So the 2 is really irrelevant. If that was an x, don't ever do that. You can't divide both sides by x. X equals 0 is one of the answers. But that's not what happened. Just want to make sure talking for all the things that we've covered this year. Okay, and then, of course, that's what... Now, I do have a point to make here. This is why I still did this one, and you better listen. This is why I still did this one algebraically, because if you're not thinking, I have a line with a circle, you would know that there's only 2 possible or less, right? Line crosses a circle twice only. Because look at what happens if you take 3 and you plug it into the circle. Okay, so if I plug in 3 here, how many y's will I get possibly out of that 3 for an x? 2 y squared. And then how many y's would I get if I plugged in 1 for x up here? 2. 2 plus 2 is 4 solutions. Can a line cross a circle 4 times? No. So the rule algebraically is this when you're solving conics. It's just one little thing to common sense what I just covered right there. You need to take the answers you got algebraically from your first step and plug them into the smaller of the 2 system things as far as degree. Of course, a line is where I want to plug this into. If I had a parabola and a circle, you should plug it into the parabola. Because why? A parabola has what? Only one of the terms being squared. Okay, so you don't get a false positive. You don't get false coordinates that aren't really solutions to the system. So I got to plug this into the line. And of course, if I plug in 3 for x, 3 plus what equals 4? 1. And then if I plug in 1 for x, 1 plus what equals 4? 3. So those are the solutions algebraically. Do not plug them into the circle. You plug them into the less complicated, less squared thing. Now, with all that being said, now look at what we have here for, look at this. Now, no more sketching. I was just doing that for review purposes, all-encompassing, starting our review process for the test Wednesday. Look at how easy this is. It's automatically set up for what? Elimination. And the Algebra 2 book that I used this from was real nice. just to get a concept down for you. Hey, by the way, what are these pictures of? This is going to make me sad. What's the, I do, it does matter, because we should know. It's a hyperbola. Okay, got a lot of people licking the walls right now, not paying attention. Okay, what's this one? What's the next one? Is it a hyperbola, circle, ellipse, parabola, line, picture of Mr. S? It's a hyperbola. Yeah, one of the squareds are minus. But when we go ahead and add these, those cancel. That's why it's set up perfectly for elimination. Like I said, the Algebra 2 book back in the day was real nice for that. And then what do I have to do? I have to plug all day long. I think I plugged it into the top one. It doesn't matter. They're both double squared. They're both, either one in this case. There is no line with a hyperbola, so I don't have a line option. All right. So based off that last thing I said, I could do either or, and one isn't any better than the other as far as work is concerned. So. All right. Hey, what's 4 minus 4?
0.
What does that mean, y equals? Burn, baby, burn. Disco Inferno. Plus or minus 1. Someone said 1 again. Okay. So, what are the coordinates? 1, comma 1, 1, comma negative 1. Fumble. Next one, isn't this fun? I'll press pause for a second. The test is Wednesday.
Why?
Okay. All right, that's good. All right, so here we go. What's this? What's this? What's this?
Circle. No. Hyperbola. Ellipse. It's an ellipse.
What's this one?
That's a
Circle.
circle.
Yeah. Okay, just for fun. Is it ready for substitution? Not quite. Leave those alone. Seriously. You don't take notes. You're sitting there playing with my markers. That's what you're doing. Okay? All right, so here we go. Multiply by a negative. And I picked that bottom one because it's nicer. Because then this will end up being a positive y squared. Minus 3y plus 2 doesn't or are not like terms. 0 plus 0, 0. Okay, then you what? Factor. You factor. And I'm flying through factoring because I should not have to teach that at this point. MA, there we go again, teaching it. What multiplies a 2 and adds a negative 3? Okay, so y equals 2 and y equals 1. And I'm doing this on purpose, writing this like this so that you really see the next part. Okay, now I'm going to go back to this without the negative thrown through, so back to this original. And I guess since the video is there, I can. Okay, so now I'm going to go back to that original, and the bottom one seems a little bit less involved. So I'm going to do x squared plus 2 squared minus 2 equals 0. Now I'm going to plug this in, and then I could move this down and work on evaluating. Okay. I'm still going here, right? Nice. Hey, isn't 2 squared 4? And x squared plus 4 minus 2 is plus 2? And that means x squared equals a negative 2? What kind of answer am I going to get out of that? Imaginary. What does that mean about y equaling 2 as a y coordinate for... This means this is not a real solution which will not graph on a real coordinate plane. So therefore, it is not an intersection between these two graphs. Therefore, it's dropped. Okay, but then the other one, and what if the other one that happens? What if both of them that happens? Then they don't cross. And that's where you run into no solutions. That or the more specific thing that occurs. Now just realize that the worksheet that I made for you, I should have left it. What if you lose all your variables and you have a false statement listed after that? Well, then that means no solution as well. That goes back to the days of just solving a system with lines. And then what's x equal here? If you make the same mistake again, thank you. Oh my gosh. Okay, now you got to be careful. It's x comma y. So when I plugged in 1 for y, I got a positive 1 for x. And when I plugged in 1 for y, I got a negative 1 for x. And it's just a coincidence that they're similar to last questions. The Algebra 2 book kept them easy as far as the answers what they got. All right? And then we're going all the way here, folks. So the last one. What's the first thing? Add 9, and it's a circle. What's the second one? A line. Circle a line, cross maximum twice. Now, second hour, I solve for x. It's actually a little bit easier to solve for y. Add 1. Because then I'll only have to FOIL once. So I'm going to plug that in for there, and that x squared gets to stay there. So sorry about that second hour. We took a little bit more challenging approach. I plug in negative x plus 1 for y. Then I simplify. And then I FOIL. So x squared plus, good FOILers, by the way. Negative x times negative x, positive x squared. Negative x times negative 2 is 2x times 2. Negative 2 times 2, negative 2 is 4. By the way, why did it all become positive? What's a negative squared? And that's why all the terms ended up being positive, because you always had a negative times a negative. Okay, but then, oh, you're gonna hate this. 2x squared plus 4x minus 5, which is not factorable. If it's not factorable, you have to go to the what? Negative. Let's do it. Wait, the opposite of b, plus or minus b squared minus 4ac. Get ready for the end. All over 2a. Okay, now, at this point, I'm going to show you, I cut and paste my key from last year for this. No time. No time. We'll go back to you out of the video. Okay, what you should do on this then is get the decimal. And this work should make sense. And by the way, what did I tell you? Should you take your x's and plug them into the circle or the line? The line. If you plug it into the circle, you're going to get 4 solutions. A line cannot cross a circle 4 times. So what you need to do is just get the decimal from the quadratic formula, and then don't make a big deal out of it. You get the decimal, x equals 0.87, and just plug in 0.87 for x, and then type on your calculator what does y end up being as a decimal. And then, yes, and then negative 2.87 is negative 4 minus root 56 over 4. Then plug that. Now, do understand it was negative x plus 1, so that becomes positive 2.87 plus 1, which is 3.87. So those are the 2 coordinates, and therefore graphing that would not have been fun, because that would have been an ugly answer.